evening, depending on the time zone you're in. I'm your presenter now, Rajaseeman, presenting on governor limits and Apex best practices. So I guess everyone can see my screen. Yeah. So welcome to the Salesforce for developers. And here we go. Before I begin, just a quick note that you should base your purchasing decision on the products and services that are currently available. Salesforce is a publicly traded company. Customers should make buying decisions only on the products commercially available. Okay, now let's jump into the governor limits and let's see what it is. Okay, so the first slide says what and why governor limits. So here you go. The first point says it is a multi-tenant awareness, right? So multi-tenancy is the fundamental technology that cloud use to share IT resources cost effectively and securely with complete privacy for other tenants as well. So this is something like a common infrastructure that you have, and the clients uses a part of it, and Salesforce bounds that with the privacy with the other tenants. Okay, and we have a Apex runtime engine that strictly enforces a number of limits to ensure that code doesn't monopolize shared resources, and on crossing the limit, the transaction will be halted and rolled back. And a most important point is that limit exceptions are not catchable here. So this is the main thing that you want to understand, what's the governor limit here and why it is in place. Yeah. And on the next part, we'll go into types of governor limits. These are the types of governor limits that we have, and we'll go in depth in upcoming slides. So we have per transaction Apex limits, static Apex limit, size specific Apex limit, push notification limit, Apex per transaction certified managed package limit, and lightning performance platform Apex limit. Okay, so here we go. So this is the first point that we saw, and the type of governor limits per transaction governor limits. Okay, there are a lot of limits we have to put into our head. For now, we are checking only few important limits. Okay, so I guess we have gone through SOQL, DML, and stuffs. So here we go. So the first one is the total number of SOQL query that can be used in a transaction. So we have two different kinds of transactions. Okay, so the first one is the synchronous transaction, and the second one is the asynchronous one. So synchronous one, as we said in the previous presentation, it is end to end. So when you click a request, it goes through the request, and that's the end of the request. And for asynchronous, we hit a request, and it processes the request asynchronously and will never wait for the transaction to end. Yeah. So the first one is for synchronous transaction, the SOQL query limit is going to be 100. You can't have more than 100 synchronous limits. And for asynchronous transaction, you cannot have more than 200 SOQL queries. And on the second point over here, for each and every transaction that is made, SOQL query can return only 50,000 records, not more than that. If we end up with more than 50,000 records, and the Salesforce will throw error. Yeah. So those are the SOQL limits and total number of SOQL records that can be returned via SOQL query. And I'm sorry. And the third one is the total number of SOQL queries issued. Sorry, SOSL queries issued. So Salesforce has two kinds of queries, right? As you can understand. So SOSL and SOQL. So here we are going to see about SOSL limit and the number of records that can be retrieved by a SOSL query. So the limit is 20. You can use 20 SOSL requests, and the number of records that can be retrieved via a SOSL query is 2000. And here comes the part where we have to use the number of, sorry, something is happening with my system. I'm sorry. Okay, so we are back. So the number of DML statements that can be issued is 150 per transaction, both synchronous and asynchronous. And the total number of record that can be processed in a transaction is 10,000. So this is what we have with us. And the number of callouts that can be that we can do within a transaction is 100, and each and every transaction can have cumulative timeout of 120 seconds, above which the transaction will be terminated. And here are a few important points that we have to note. And the first one is the maximum number of methods that can use future annotation. So this is something like a future method is something like a method that is going to be called, but it will run in the backend asynchronously. Okay. So on the synchronous limit, we can call 50 methods, future methods, and 0 on the batches on future context, and 1 on the queryable context. Okay. This is for a synchronous limit. And the maximum number of Apex jobs that can be added into a queue using system.enqueue job is 50 for the synchronous one and 1 for the asynchronous one. And here you go. So we have a method called send email. So it sends out, it sums up all the email that we need to send, and a message is put into send email method, and then the email is sent across. So the number of send email methods allowed per transaction is 10, both synchronous and asynchronous. Yeah. And the total heap size is something like a space that is being used in the transaction. So in order to store any data that is required for the transaction. So for synchronous, you can have only 6 MB, and for asynchronous, you can have 12 MB. Yeah. And this is the one of the important thing that we have to note. It's the maximum CPU time on Salesforce servers. Okay. So this is something like for synchronous transaction, whenever transaction is hit, it should be executed within 10 seconds, which is 10,000 milliseconds, of course. Yeah, for synchronous one, and 60 seconds or 60,000 milliseconds for asynchronous ones. Yeah, and the maximum execution time for each Apex transaction, it can be a class or method or any invocation that has happened, it cannot cross over 10 minutes. So that's the limit that is bound for now. Yeah. And maximum number of push notification methods that can be called per Apex transaction is 10, where each and every method can have a different notification, but summing up all those notification, it can have only 2000 notification method calls. Okay, so that's the number to keep for now. And let's jump into the static Apex limits. So the default timeout of a callout is 10 seconds, right? Yeah, we have seen on the previous slide where it says 120 for the cumulative one, and the default timeout of a callout here is 10 seconds. And maximum callout size can be 6 MB for a synchronous Apex and 12 MB for asynchronous Apex. And the and when you request query to Salesforce server, and when the request exits more than 120 seconds to process those query, then Salesforce automatically cancels the transaction, and error will be thrown. Yeah. And the maximum number of characters, sorry, the maximum number of class and trigger code unit in deployment of Apex is 5,000. You can't deploy more than that. And Apex trigger batch size can be 200. So you have to be a bit careful on the limit that is mentioned over these two things, where even though if you send more than 200 records to a transaction, on both Apex trigger and list batch size on the for loop, it is going to be 200. Okay, so these two are one of the important consideration that you have to keep in mind while coding. And what if you have more than 10,000 records per transaction, and of course we'll be using batch classes. So in batch class, if you use database.queryLocator, it is going to be processing, you can process till 50 million records, yeah, using this database.locator method. And these are few size specific Apex limits, where the number of characters of a class or a trigger cannot go more than 1 million characters. And the maximum amount of code can be used by all Apex code in an org is 6 MB. Okay. And on the for last, the method size limit is 65,535 byte codes. So this is all in all in a compiled format, where the spaces and other extra characters are commented out codes will be will not be considered for this. Yeah, so this is what we have for now. And here we go, let's come to an interesting part. So there are few commonly found limit exceptions that we used to face in Salesforce. So the first one is the too many SOQLs. As we said, the number of SOQL per transaction is going to be 100, right? So if you have more than 100 SOQL statements in per transactions, then you'll run into a issue called too many SOQL. Okay, and we have too many DMLs error. This will be thrown when for synchronous transaction, when you go more than 150 DMLs per transaction, you'll run into this issue, of course. And CPU timeout, as we said earlier, as we seen earlier in the previous slide, the CPU timeout for synchronous transaction is going to be 10 seconds, and for asynchronous transaction, it's going to be 60 seconds. When the limit crosses these limits, it's going to throw an error called CPU timeout. Yeah. And too many feature method invocation, as we know, if a transaction is calling more than 50 feature methods, it's going to throw an error saying that you have called more than 50 feature method here. Yeah, and we have the total heap size error. As usual, we have seen the limit in the previous slide. If you run over this particular limit, then Salesforce is going to throw you an error saying that the total heap size is exceeded and terminates the transaction. And for the last commonly found list exceptions, we have too many records retrieved by SOQL or SOSL. Yeah. So as we know, we can have only 50,000 records retrieved by SOQL and 2,000 records retrieved by SOSL. So these are cumulative limits. When you run over this limit, you'll go be in trouble. Yeah. And for the next one, so these are a few calls that includes DML count. Okay, we might know this. Say for example, insert, update, delete, and undelete. This is gonna cost a DML count. And on the flip part, we have database.insert, database.update, delete, database.undelete, and database.empty recycle bin on the left side of the column. Yeah. So on the right side, you have upsert, merge, approval, database.convertly, database.save, set save point, set rollback, publish, and run as. These are all the DML commonly used DML statements that consumes DML count. Okay, and here I would like to mention something on what's the difference between insert and database.insert. It applies for everyone, everything where it says update and database.update and etc. Okay, so insert statement is something like whenever something goes wrong in insert statements, the transaction is terminated and you're done with that. Okay, and here database.insert, in the other hand, has few more parameters to accept, so that it will allow partial insert or partial update in case of database.update, etc. so that whatever has failed doesn't affect the transaction. Okay, so these are all the DML counts that includes whenever you call this particular thing. Yeah. So I guess enough of boring numbers. Who doesn't like a break after a math class? Yeah. Here you go. We shall have a small break for 5 minutes, and I guess we'll resume back. Until then, back to Shagar. Yeah.
Looks like someone had a question.
Java, Spring Batch, or Python. And MuleSoft is something which we are looking at it because it is as a way to improve the productivity of our staff members, because writing everything in Python and Java, it is considered as, especially all the procedural languages, it is considered as taking a long time. So evaluating MuleSoft, at least in my view, but we haven't decided yet. But if you look at the job descriptions and listed in Fidelity, both in US as well as India with respect to Salesforce related positions, you will see either Informatica or Java, preferably with Java background.
Okay. And in fact, even MuleSoft, when you have to develop any components in MuleSoft, it's on Java, all in Java anyway, right?
Yeah, so the framework, right? So the framework is different. So we use Spring Batch framework, but MuleSoft has the framework to speed up the activities. Yes, you are right.
Right. So Java skills will take people a long way, at least in the MuleSoft domain. But when it comes to Salesforce development, it's a different ballgame, right? It's all.
Yep.
All right. Thank you for your comments. Do you have anything else to say?
Yeah. So the with respect to integrations, I think the concepts which Mahendran outlined, so that is very critical for any new developers or aspiring developers. When to use which APIs, which whether put or post or patch or get or whatever the options are, and how the APIs are structured. I mean, if you closely look at the way Mahendran showed inserts as well as updates, the structure of the APIs, there's a lot to learn from those basics, and that is very, very important. And whether you are a Salesforce developer or whether you are a Java developer, if you happen to work on API based integrations, that is very important. That I would emphasize, because when we bring on new people, and that is a part which takes little time for them to understand if they come from a non-API background.
Okay, thanks for your comments. Let's have the next presenter come in. Thanks again, Murthy.
Welcome.
Great. Thank you, Andy and Murthy. Let me continue my slide. Let me share my screen. Okay, I guess you guys can see my screen. See my slide. Let me stop and share again. Sorry. Okay, can someone acknowledge that I'm sharing my presentation?
Yeah, we can see your screen, Seeman.
Okay, so let me continue on the Apex best practices. So we are done with the boring stuff on the numbers, and let's go into the fun part. Yeah. So these are the best practices that we are going to see, and the first one is code only if in need, and we'll go on. So we will have each and every explanation with the example in the next slides. So let's go. Okay, so the first point is code only in need. Second one is keep simple and clean, always bulkify, no query or DML in loops, use map to query, use relationship in queries, have filters or limits in query, one trigger per object, keep business logic out of trigger, meaningful unit tests, use limit methods, appropriate use of asynchronous apex, avoid hard coding IDs. Okay, so these are the best practices that we are going to see now. And the first one, let's go in depth of what do you mean by code only when needed. Okay, so Salesforce is a platform, as you know. It also gives us more configurable terms of solutions that you can do point and click, enter few values if needed in the text box or number box, and click OK and go on. So few point and click solutioning methods can solve your requirement. So first thing that you have to do is analyze your requirement. Okay, so once you analyze your requirement with the knowledge of you having in the Salesforce platform, you have to choose whether it is achievable via click and point and click, and if not, you have to go to the coding part. Yeah, so this is the limitations when, sorry, if you want to code, you should justify yourself that point and click has few limitations that doesn't fit under your requirement, and so you're doing it. Yeah, so that's the first point. Second point is keep simple and clean. Yeah, so I know few developers used to code a little bit more than what is required here. Yeah, so few key points to highlight here. Okay, the first point is reuse as much as possible. Say for example, you create a method and put it in a common utility method so that you can call that particular common utility class each and every time when you want to have that particular logic. Yeah, keep as little logic in methods. So this means you have to fragment your commonly used methods into pieces so that, for example, if I can say, you can have your service class separately, you have your a transformation class separately, you have your rest method separately, so that you can combine all these code into one single class whenever needed. Yeah, and the third point here, which we want to highlight, is combined statements. And the fourth point is simple code is easier to maintain, of course. Yeah. So when there is a, for example, when there is a new field that you introduce into an object, you can directly go into the service method, add that particular field, and you're good to go with the rest of your logic. Yeah. So let's see an example here. So on the top, you can see we have queried a vehicle over here, and we have iterated over the particular vehicle to put into a map, and then we are returning a map of ID comma vehicle. Yeah, so this can be shrunk into a simple format. This is one of the best practices where we can query the objects directly into a map and then return it. Yeah, so this is one of the examples. Let's go into the next one. Bulkify your code. This is one of the important thing that you have to keep in mind, so that whenever you write a code, you keep in mind that your code has to handle more than one record at a time. For example, when we take triggers, more than one record, say for example more than 200 or thousands or 10,000 which we have in a transaction can come into a trigger, and this particular trigger has to handle all those 10,000 records. Of course 200 in a chunk, but still 200 is a lot of records that needs to be handled in particular class or method. Yeah, and second one, avoid repeated queries and DMLs. As you know, we have limits that is applied where you can't go more than 100 queries and 150 DMLs in a transaction. So keep in mind that you never cross over those limits, that as we seen on the previous slides. Yeah, reduce database transactions, which means either you query it or use DML or stuffs, and these are because you have to avoid kernel limits. Yeah, once you hit the governor limit, your transaction is going to be terminated and you're done for the day. Yeah, so you have to keep this in mind. And there is one thing which we used to follow. So whenever you write a method that accepts something as a parameter, write it as a collections like list or map, so that we can send a bulk of record into it and return a bulk of record from that. So for example, you have it here. Okay, so here we can see a list of trip is being queried. Yeah, and this method on the top is not bulkified. Okay, and on the bottom you can see the code that is bulkified here. Okay, so here you can see in the non-bulkified version, it accepts only one record, which is vehicle, and then process that particular vehicle and returns the trips related to the vehicle. Yeah, but here on the second part, here see you see we get a set of vehicles which can be more than one vehicles, of course. Yeah, and using those set, we are querying the trips related to the particular vehicle, and then we are sending out a map of vehicle come on list of trips to the method that is called by that is using this particular class. Yeah, so that is what we have here. So in short, write your method or code that accepts bulkified records like collections, for example, set, list, or map, so that whenever you put something over here, this method is called, and the method handles bulk data and returns you response for these bulk record that you need to process. Let's go on to the next one. So this is one of the important topic that we have to see. No query or DML in a loop. You know why, right? So when we know a list of loops that you can use, for example, for loop, right? So what happens when you put a query statement, say for something like a SQL statement inside a for loop that iterates more than 100 times? You'll run into an issue, right? Because as we seen earlier, the limit for the SQL query is 100 per transaction synchronously, right? So if you go more than that, you're going to be ended up into an issue where you run out of the limit, and governor limit throws back an error. Yeah, so be mindful that you do not put a query in a for loop or DML statement in a for loop. This reduces number of things. Okay, so first thing, resource utilization, as we know. Second thing, the processing time. You know, the processing time or the CPU time is 10 seconds for a transaction. Number of trigger invocations. So I guess you already know whenever a DML statement is executed, it follows the transactions that has to go from trigger to before trigger, after trigger, those things. Yeah, and most finally, we have to avoid hitting governor limit. That's the main point here. Yeah. So let's see the example here. For example, okay, so let's take the trip object that we have used earlier. So here, if you can see, we have a for loop over here. This is kind of a special for loop which we use in Apex. The normal for loop will have something like initialization block, increment block, and conditions, right? So this is a for loop that is being used in Apex coding, where a collection can be iterated like this. Okay, so we have a list of trip that is being iterated, and the trip is the instance of each and every uh, trips that is being iterated here. Okay, so here you can see we have added a query here, and we have added an update statement here, which is SOQL and DML that is happening in a loop. So we have to avoid this so that we will not run into an issue. Okay, so what if we have to have this particular functionality, but in a right way? This is where the developer should do. Okay, so we have the list of trips. The trip has to be the IDs of the trip has to be added, and it has to be queried on the external system. I mean external method, and we update the trip over a list and then update it out of the loop. So if you can see, this update and the query doesn't happen within the for loop, so we're good. So here the update or the query happens only once, and we are not going to hit the limit, of course. Yeah, let's jump on the next one. Use maps to query. Okay, so map is one of the collections that we have in Salesforce. So the first point is to build a map of IDs and a subject list of a subject that has to be. Okay, say for example, I have two vehicles of different IDs, of course, because Salesforce generates different IDs for the records. So map saves something like this. Okay, the ID of the record and the instance of the record, whatever is being queried here. Okay, so here you can see we have used a list of vehicle collection, and then queried this particular list of vehicles into a list, and then iterated over here to form a new map called existing vehicle map. Instead of doing these things, you can write directly a return query with new instance of ID comma vehicle map, and then query directly into it. So if you can see, the number of lines that are being used here is reduced, and this is more simplified version of it. So I guess the same example we have seen in the first thing, right? Keep it simple and clean. Okay. So next thing is use relationship in query. So of course, whenever a database comes in, we can have parent and number of children between these table. So in Salesforce, we have two relationship. One is the commonly used ones are lookup and most detailed, right? So these are the two relationships that we commonly use. And here, if you can see, for an example on the top, we have a trip and vehicle record. Vehicle is the parent, of course, and trip can be the child record because a vehicle can have more than one trip. Yeah. So instead of having two separate queries for parent and child records, we can combine those things into one single query. Okay, these we called as child relationship query or inner query. Okay, in our terms, in our local terms, of course. Yeah. So here you can see you have two separate queries combined into one. What is the use of having combining these two into one query? That may be a question, right? But as you know, this is one simple logic that we have that may not cross over the kernel limit, but consider a complex logic, business logic that requires more than 100 or 200 tables that has to be queried. In that case, combining each and every child and parent into one query will result in not hitting the kernel limit. Yeah. And here we go. Have filters or limits in query. So first question, we know we should have a filter in a query, right? What if we don't have a filter in a query? What happens? Okay. First thing is, as you know, for SOQL, whenever the number of records returned from a SOQL query is more than 50,000, you're going to run into apex limit issue. Yeah. And for SOSL, we have 2,000 records, right? So adding a filter is necessary in few cases, but we are recommending it because it limits the number of records returned from a query, and it doesn't, it gives the exact record of what you need for the process, right? One may need a record of a table which has something like a name equals Rajaseeman. One may need an entire record on the tables. It depends on the functionality, right? So use filters or limits in the query so that you never run over the heap size error where you need to iterate and keep your instance and avoid hitting kernel limits and having your processing time under the limit. Yeah. So this is the advantage, and this is what we're recommending. And one trigger per object. So you know what's a trigger, right? So whenever an object has a trigger, and event can be insert, update, delete, etc. And in our case, let's take say what happens, or can we have more than one trigger in an object? The answer is yes. Then okay, we can have more than one trigger. So why should we avoid multiple triggers in an object is the question, right? So to answer to your question is there can be more than one trigger in the object, but you will never know the order of execution. This order of execution is for trigger, not the order of execution of Salesforce thing. Okay, say I have trigger 1, 2, and 3 in an object. I will never know whether the trigger 1 ran first, or trigger 3 ran first, or trigger 2 ran first. It depends on Salesforce. Yeah, and this is to avoid redundancies and inefficiencies, because you might need to iterate. For example, you have two triggers in a contract. Okay, and for the first trigger you will still put a for loop on the new trigger list that you got, and the same will be happening on the second as well if needed. Yeah, so this is waste of time. This will hit the governor limits, and you will have redundancy of code between these two triggers, for example, that we are talking here. Yeah, so keep it simple, keep it clean, have one trigger per object, and use handler methods to handle it. Yeah. The next one, business logic out of trigger. Okay, so this is what I was talking about in the previous trigger example. Okay, so you can have only one trigger and have the business logic that you want in a trigger handler, so that you can use the other classes to be invoked from a trigger, and then handle those business logics in a different class. So this helps, because whenever you see a trigger, you know which trigger handler is called and what is the order of uh, firing that happens on a method. Yeah, this helps a lot. So so the key point is keep your trigger lightweight, and this enforces data security as trigger runs in system mode. Yeah, we'll go to the next point. Meaningful test classes, the most important point here. Yeah, whenever you write a business logic in your trigger or class or rest class, etc., you have to write a full code coverage test class, so that it covers the logic behind it. So just not write a test class to cover the code, because code coverage is important for deployment, of course. So don't do it like in order to say for example you call the particular method and cover the method. So that's not the right way to do. That is not the example that we are keeping here. Yeah, so you have to write a test class that functionally covers the logic that you have built, and it should be a bulk testing, and it should be a load testing as well in the same time, because test class are the best way to identify the performance of your class, and adding a bulk testing and load testing to it is the best thing that you can do. And the functional testing is the important thing, and the most required thing that you have to do in a test class. And use limit methods. So what are limit methods? Okay, by default Salesforce gives you few limit classes, that class methods that you can use in your code, that returns back what is the current limit usage, or what is the limit maximum limit that you can have. For example, we can take here as DML rows. What is the limit of DML rows that is being used, and what is the limit that you uh, have for the whole transaction? So it is something like the current usage and the total usage that you can maximum have per transaction. Okay, same goes for queries as well. We'll see a small demo on this in the upcoming slide. Yeah. So appropriate use of asynchronous Apex. So first thing, we have gone through different slide that says asynchronous part. Yeah. So this asynchronous part on the limit slide has few advantages, right? So they can do few limit enhancements over there, over the platform limitations. They have higher governor limits. For example, CPU time limit is 60 seconds, etc. And it doesn't affect the transaction that you have to do right away. And you don't want to wait for the transaction that you don't want a result immediately. So that is where we go to asynchronous part. There are few from the main transaction. You can do something like a future method, a batch class running in the backend, etc. Yeah. And avoid hard coding IDs. These are the. This one is a specific one that you have to fundamentally follow. IDs here, I mean, is the Salesforce IDs that is provided by Salesforce for each and every record. Of course, there are other IDs provided for classes, etc. So now here we are concentrating on the record IDs. Okay, so hard coding record IDs is not recommended because there are several things that can happen in the backend. Yeah. So the system that you're testing can have an ID, but for example, you're working on a sandbox, but the same cannot be there in the production org as well. Yeah. And hard coding IDs malfunction after deployment. This is because, as the first point says, you work on a sandbox, you deploy into production or different sandboxes, the same ID cannot be found there. And it is better to use Boolean flag in record. And whenever you use custom label, custom sharing settings, and custom settings and custom metadata, don't don't use IDs. You have methods to get those records. You can query it, or you have methods to get those record from Salesforce backend. Okay. These are the examples. Okay, so say here you can say we are iterating a contact from a trigger, and we are checking if a record type ID is something like this. Instead, we can use a method to find the record type over here. I mean a query in this instance, so that we can find the particular record type and check the record type ID. So this is the useful one. Yeah. And let's see a demo of whatever we gone through. Just give me a second. So I guess you can see my screen, the Salesforce screen. If someone can acknowledge it, that I can proceed with my. Sorry.
Yeah, we
do.
Okay, great. Thank you. So let's see a few of the limit examples that we've seen previously. So this is a developer console that I'm using for now to execute code anonymously. In the upcoming session, I guess we'll have an explanation of what and why you're using this and how to use it. Yeah. So for example, today I'm using a developer console to run this. Yeah. So the first example that we are going to see is, you guess, we are going to check the SOQL limit. So here is a SOQL query that I have done. It says select ID from account, which is a blunt query. I have done several mistakes over here because I have put a query in a for loop, which I shouldn't be doing, right? I don't have any limit or filter conditions, which I shouldn't be, which is not a recommended one. So, but I have to, give a demo on the limits. That's why I'm putting it here. So it's not recommended, but in order to show it for you, I'm just running this query. Yeah, and yes, we can run this for for loop which has initialization, conditions, and increment or decrement point. Yeah. Okay. I'm executing this particular query. Let's see what happens. You see, we have a two-minute SQL query, as we seen on the one of the slides, which says commonly found limit exceptions. Right. This is one of the exceptions. This is because, you know, for synchronous transaction, we cannot have more than 100 SQL queries. If I say I put 100 here, let me execute. See, the transaction has been completed. So when you cross over 100, you will have a issue on the SQL limit. So this is one of the limits. And the next one is the DML part that we know. Yeah. So the same goes here. I shouldn't be doing a for loop. I shouldn't be doing a update on inside a for loop, which means a DML. And the right way of doing it, doing a contact. An example is here. Yeah. So I'm querying a contact which has last name is equal to Raja. Yeah. And I'm updating it over here. So I'm updating it more than 150 times. So let's see what happens. So you can see too many DML statement has come up and it says 151. It should be 150. Yeah. If I give 150 over here, this is gonna update it. Yeah. Yeah. The transaction is complete. Okay. So as we seen previously, what should we do in order to check what's happening in the backend? That is where one of the best practice says you have to use limit classes to find what's going on in the backend. Yeah. So here is an example of how you need to do a query and how to find the limits that is available. Yeah. So what I'm doing is I'm still here doing a blunt query which doesn't have any filter, but I'm still querying it. So let me execute it. Let me filter it based on the debug log I have put. So you can see here the total number of queries that is allowed in Apex code context is 100, out of which I have used one, because I have used one SQL query over here, so it has been consumed. Okay. So using these limits over here, limits dot get limit queries and limits dot get queries. So these two will return. The first one returns the maximum number of queries that you can do in a transaction, and this one gives you the current limit that is being consumed by the user. Yeah. So this one is for the queries, and I have an example for DML as well. So let's check that. So I have a contact open over here. It says Raja. Yeah. So what I'm going to do is I'm going to update that particular contact as Simon, and I'm going to update it and check what happens in the backend. Yeah. I'm executing it and I'm seeing the log. So it says, as we know, as we spoke earlier in the presentation, we know the total number of DML statements that is allowed in a transaction is 150, and so far we have used one particular DML call. Yeah. And this DML call is captured over here. So if you can see the limits, you can see limit methods. You can see we are still using the limit class and get limit DML statements to get what is the maximum transaction, DML transaction that we can do. I mean, maximum DML statement that is allowed per transaction in this case, and limits dot get DML statements to know how many DMLs I have used so far. So this is the demo that you see here. Yeah. And voila, we're done for the presentation now. I guess I'll be getting your questions on the chat, and we'll be replying back your questions once we gone through it. Yeah, great. Thank you. Have a good day, and we'll continue with the next presentation. Back to Padmashekhar. Cheers.